hit record, we had some COVIDers out there. So we've lost some people in the class. Okay. All right. I think we're ready. We're gonna pick back up on we finished 108, so we're ready to jump into 109 is I think where we are. Okay. Sound good? Anybody have any questions before we jump in? Okay. All right. So, okay, here we go. 109 wants us to use a triangle, and it gives us some information about the triangle, but all it gives us are the sides. So if I label them, my triangle is going to look like this. Okay, and all I have are the sides. All right, well, this is not a right triangle. And can I use law of sines with this guy? No, because I don't have any angles. So I don't have all the information for one of the letters. So I can't. That means that we're going to have to use the law of cosines. So if you remember, I did put one law of cosines up there for you. And I had already solved it. It was the version for C, which is what we're going to use. Now, why are we going to use the version that involves C? Because it's the biggest. Remember, law of cosines likes the bigger angles, right? So we're going to use this one, which is the one that I had up there anyway. Okay, and there we go. All right, we're going to have to solve it a little differently though, right? Because we have the sides. We're just going to need this cosine C angle. So we're going to plug in what we have, and then we're going to go from there. Okay, notice your directions say degree. So we're looking for degrees. Triangles, we always look for degrees, but okay, so we're going to have 6 squared equals 5.4 squared plus 5 squared minus 2 times 5.4 times 5. Oh, I ran out of room. Times cosine C. Okay, squished it all in there. All right, so what we're going to do, we don't have any of these little middle steps worked out. I guess I should, just to make sure we can do it all. Okay. So I think everybody can see that on both screens. Okay, so I'm going to do 5.4 squared plus 5 squared. That's going to give me 54.16. Okay, minus, and then I'm going to do 2 times 5.4 times 5. That's 54 cosine C. Okay, is everybody all right with what I did there? I just squared these two and added them together. And then I multiplied these 3 together and put it in front of cosine C. Okay, now I'm trying to get cosine C all by itself. So now I'm going to subtract the 54.16, 36, but this one comes out, okay, minus 54.16, I get negative 18.16 equals negative 54 cosine C. Okay, everybody good there? All right, I'm going to divide by negative 54. And I come up with 0.3363 equals cosine C. Okay, everybody good up to that point? Okay, now I need I need angle C. So what am I going to do to get angle C? Inverse, making sure that I'm in degree mode, which I am. So second cosine, 0.3363. And I get an angle C of, let's see, angles, it just wants rounded to the nearest degree. So 70 degrees. There we go. That's my angle C. Everybody okay with that? Okay. All right. Now, I still need to get one more angle before I can do the 180 minus the two angles, right? So I could use law of cosines one more time if I wanted, but do we want to do that? No. What are we going to switch to? Sine, law of sines. Now here's the important part. I know we're kind of running out of room here, but you don't need a whole lot of room for 110. So, okay, so I'm going to switch to law of sines. All right, but who am I going to solve for in this case? If I use law of sines, am I going to solve for angle B or am I going to solve for angle A? B. Why am I solving for angle B? It's the smallest. Okay, now it may not make a difference with this particular problem, but on the test, it will make a difference. So when you switch to law of sines, you want to find the smallest angle. And then if you want to make a note, when you're using law of cosines, you want to find the largest angle. Okay, that's what they were designed for. And there are instances where it's going to make a huge difference and your final exam is going to be where it makes a huge difference. Okay, so I'm going to be solving for angle B. So sine B over his side, okay, equals sine of 70 over side C. Okay, everybody okay with how I set that up? I didn't really label it too much, but you good with that? All right, so I'm going to do, right, 5 times the sine of 70. Okay, I did 5 times the sine of 70 divided by 6. That gives me sine B equals 0.7831. Okay, is everybody okay? I multiplied these two, I divided by 6. All right, then again, I'm going to be doing second sine, my inverse of what I just found. And then I'm going to round. And I got a nice little 52 degrees for him. Okay. All right, then how am I going to find angle A? Yeah, good old 180 minus 52 minus 70. This is going to give me angle A, and he comes out to be 58 degrees. Okay. No, no ASS situations, none. Just the, yeah, just the triangles that are on the test. That's it. I mean, on the review. Okay. Sound good? So that one's kind of involved. Just make sure you remember how to do both of those. Okay. All right. Okay, so 110 says graph. Well, you know you're not going to graph. You're going to choose 4 pictures from the graph. Okay, so all you should have to do is plug this little dude right into your calculator. But we have to work on some stuff. So what mode should I be in if I want to throw him into my calculator? Radians wouldn't hurt. And what other kind of mode though? Polar. Okay, make sure you're in polar. Radians certainly doesn't hurt. Some of y'all need radians in your calculator. Some of you don't. Some of your calculator kind of handles it for you, but it wouldn't hurt to get both those in. All right, so I'm going to go to y equals, which is now r equals, right? I'm sorry, I can't, my recording can't do it. Go ahead.
How do we get it out of this? And I
No.
forgot.
Oh, just one more stressor. Okay, so I'm going to put 5 sine 2 theta. Remember, your theta is now your little variable button. And then you just hit graph. If it's being a little weird for you, go to zoom standard and it'll make it nice, or zoom square. They'll both make it nice. And then here you go. And that's all you have to figure out is match it up with that picture and you're done. Okay, that's it. So if you really kind of want to know, right, like all about it, you're going to know because it's a 2 theta and it's an r that it's a rose. You don't have to write any of this, but just kind of so we remember. Okay, It's, let's see, petal length is 5. That would be our petal length. Okay, and then our number of petals, we're gonna take the 2, and because that's even, just a sec, I'm gonna multiply it by 2, and you should get 4. Okay, go ahead. Okay, so go to mode. Make sure you're in radian, just because sometimes it matters, and then scooch over to POL. Got that? Okay, now second mode, you want to quit. Okay, now if you go up to Y equals, now it says R, like R1. Okay, and then you're going to do 5 sine, 2, and then this button right below mode is where you get your theta from. And then close it. And then it should graph. If you don't have the right window, you can hit zoom square or zoom standard and it'll give you the right window. Did it go? Okay. All right. And then that way you don't have to really remember anything about the graphs. Did everybody get their graph okay? Okay. But if you wanted to know why, this kind of tells you why. We had to multiply 2 times n because n was even. This is your n. Okay. And that's also how you can tell it's a picture, just in case you wanted to know. All right. Sound good? Okay, let's flip on over to 111. Okay. All right. Okay, so 111 is kind of strange because it's left over from, they just don't really update our finals very much. They kind of cycle them. And unfortunately, this guy got left over from a couple of books ago. So we haven't really seen arc secant before. But do you remember what I told you arc really does stand for, even though our book doesn't use it? What does an arc really mean? Inverse. Inverse. So this is exactly the same as if you saw this. Same thing. It's an inverse. I know. I don't know why they do that. It's just, but I'm not on, listen, I'm not on the final exam committee. And if anybody nominates me, you're dead to me, right? So I'm just going to take it and we'll fix it. But I don't need one more thing to do. Okay. So anywho, they left an arc problem on there. We're going to pretend it's an inverse because it's the same thing. It's just that's what they used to call it in the olden days when I was in school. Okay. All right. Here we go. So we know about our inverse buttons, right? So let's go back to where we were. Okay, now this is going to tell you, use the calculator to find the real number value. This is code for radians. So you need to be in radian mode. Now that works out great for us for this study guide, because what did we do? We just followed a problem where we were in radian mode. What if you follow a triangle problem? You're going to be in degree mode because you were just in a triangle problem. Make sure you realize it has to be in radian mode, okay? Because I'm not sure how tricky they are. They may have the answer if you had left it in decimal mode. So you want to make sure that you're in radian mode. That's what that real number value means. Okay, so you know that your inverse buttons are the seconds, right? So second sine, second cosine, second tangent. Problem is we're second secant. Well, they're in the second secant because they're in the first secant, right? So how are you going to find inverse secant? Remember, what's secant the reciprocal of? Cosine. And again, that's something you may want to write on your index card if you're not so sure about it. So I'm in radian mode, okay? What this really means, it's the same as the inverse cosine of 1 divided by this number, okay? You would just flip that number, and that's how you're going to get your answer. Okay, so we're in radian mode, and I'm going to do second cosine 1 divided by what they give me, and I get 1.20. Okay, so I'm 99% sure you're going to have an arc secant, but let's just talk about what if this were arc cosecant? What if this were arc CSC? How would you find it? inverse sine 1 divided by whatever the number is, right? So make sure, you know, worst case scenario, you end up in that situation. Okay, but I'm pretty sure it's this one. Okay, that's just calculator knowledge. So make sure you're good. You should get 1.20 when you round it. Okay. All right, let's see, brings us to 112. Okay, my goodness, dig deep. This is January, like first week of class. I think the first class. Okay, so find a circle of radius 9.3 centimeters. Oh, for a circle, I'm sorry. Find the arc length S subtended, remember this just means created, by a central angle of 3 pi over 4 and round to the nearest hundredth. Okay, this is already something that was on your formula sheet that I gave you, is to make sure we do this. Also, let's make sure we know what this is. This is your arc length. This is your radius. Notice they're going to give you a radius, so there's no tricking here. They're not going to give you a diameter. You don't have to divide it by 2. They give you the radius. This theta has to be in rads, and they're going to give it to you in rads. No tricky here. It's just simply multiply the two numbers together and round. That's all you have to do, okay? It's really straightforward. Okay, so my radius is 9.3. My theta, already in rads, 3 pi over 4. Okay, we're going to do 9.3 times 3 pi divided by 4. And we're going to round it to 2 decimal places because that's the hundredths place. You don't have to worry about units if you don't want to, but it's the same unit as the radius. So it's centimeters in this case. Okay. Anybody even remember that? Maybe a little. Yep. Okay. So okay. We good? All right. Yeah, those are things we got to ask now. I know. Okay. All right. We got it? Okay. All right. We're ready for 113? Okay. 113 tends to bother students. This was missed a lot on the test when we did have it on its test. So if you notice up there on the board, I gave you another one if you want to try it. He's number 47. So if you decide you need a little practice, it wouldn't hurt you to go back and do number 47 on your own. The answers are in the back. Okay. But let's see what we got here. Okay. Notice what it wants. It wants cosine alpha plus beta. All right. That I already gave you, which is going to be cosine of alpha times, cosine beta. All right, minus sine alpha, sine beta. Okay, so you need 4 things. You need cosine alpha and sine alpha, and you need cosine beta and sine beta, right? Not in that order, but that's what you're going to need to plug in here. And they're going to be little fractions and you're going to multiply them by each other. Okay, so what we have here, I wish I had more room on here for you. I don't really have a lot of room, so I'm going to make this. Okay, so what I have here is I'm going to make a little chart for alpha, okay? Then I'm going to make a little chart for beta. That's what I'm going to make. Little chart for alpha, little chart for beta. So maybe over here on the side somewhere you can make it. I'm just doing it so I have big enough room. Okay, so first of all, let's figure out what's going on in alpha and beta, because what I want is to find the X, the Y, and the R for alpha and beta. That's what I want, because I've got to create cosine alpha, which they happen to give me. Then I have to create cosine beta, which would be X over R. I have to create sine alpha, which will be Y over R. And then I have to create sine beta, but they gave me that. Okay, so I'm going to have to make these. All right, so let's talk about alpha first. They gave me cosine alpha. Cosine is X over R. Okay, and then they tell me what quadrant I'm in. So what quadrant would give me pi over 2 to pi? What quadrant is that? That's quadrant 2, right? Here's pi over 2 to pi, in case you couldn't understand my flailing arm, right? So that's quadrant 2. Okay, the reason they give you that is so you know who's positive and who's negative. Okay, all right, so my r has to be positive, so it's going to be a positive 5. My x is going to be negative 4. X is negative in quadrant 2, so that must be who the negative goes with. Everybody got that okay? So now I'm missing y. How can I find y if I have x and I have r? X squared plus y squared equals r squared. So I'm going to have negative 4 squared plus y squared equals 5 squared. Okay. I don't think I have this worked out, but anyway, what it boils down to is y squared equals 9. So y equals 3. Now, how do I know it's a 3 and not a negative 3? Yeah, well, and we're in quadrant 2. Yeah, and in quadrant 2, y is positive. So it's got to be a positive 3. Okay, my alpha information has been gathered. Okay, now I'm over here with beta. Okay, so sine beta, this would be y over r. Okay, so my r is 5, right? And my y is negative root of 21. Okay, all right, what quadrant is beta in? It's from pi to 3 pi over 2. Quadrant 3, from pi to 3 pi, oh, you can't see. From pi to 3 pi over 2. So it's in quadrant 3. Okay. Okay. So now I need to find x. So for beta, I'm going to have x squared plus a negative root of 21 squared equals 5 squared. Okay. This is going to be x squared plus 21 equals 25. X squared equals 4. X equals 2. Is it a positive 2 or a negative 2? Negative. How do you know it's negative? It's in quadrant 3. Okay. So now we have all the information that we need. Okay. So when you get to the alpha beta situation, make yourself a chart, pay attention to the quadrants, and get all the X, Y, and R's. Everybody got it? Okay, now we're ready to handle this. Okay, so first of all, I need cosine alpha. So that's negative 4 over 5. Okay, cosine is x over r, and they gave it to us. Okay, now I want to multiply that by cosine beta. Okay, so I go over to my beta side. Remember, cosine is x over r. So negative 2 over root of 5. I'm not root of 5, over 5, sorry. Okay, minus. Okay, then sine alpha. All right, how do you make sine? Y over r, right? So I go over to my alpha and I take 3 over 5. Okay, times sine beta. I go over to my beta and I do negative root of 21 over 5. Also, they already gave us that. Okay, does everybody see how that happened? Okay, so this was will have to come off of your little card. Hi. Right here? Oh, that's just part of your formula. That's part of your formula. I know it says plus here, but it should be cosine alpha, cosine beta minus sine alpha, sine beta. Now, when these multiply together, you're going to get a plus. Does that make sense? Let me make sure I didn't write it wrong. No, here he is. Okay, so here's your cosine alpha plus beta. Here's your formula that you're going to want to use. There's a minus in between there. Okay. No, just that one. That's the only one you're going to need. I don't want you to take up any extra room with stuff you don't need. Okay. Are we good so far? Okay. All right. So negative 4 times negative 2 is positive 8 over 25. 5 times 5 is 25. Okay, so we already said minus and negative is going to be positive. 3 times root of 21 is 3 root of 21 over 25. All right, and the answer choice you're going to see just combines both of these guys in the numerator. And that's the answer choice you're going to have. Okay. Everybody okay with that one? That's a lot of information. So it's testing you on this formula. It's testing you on your quadrants, who's positive or negative. It's testing you on, do you know that cosine's x over r and sine is y over r? It's testing you on x squared plus y squared equals r squared, because that's what you're going to need to get the other letter for alpha and beta. I mean, it's a lot in one problem, okay? But it's not hard, it's just a lot of steps. So if you're worried about it, try number 47. And that'll help you do one more like it, okay? Or take a couple of extra final things with you. College algebra, everybody in that class takes like 5. And so I always make lots of extra copies. So you guys can take some more copies and treat it like a test if you need to. All right, good on that one? Okay. All right. Let's see. We don't need 114. So I could have just worked right on into his area. Sorry. Okay, 115. 115. We're doing another one like this just to make sure we can do it. We've already done one like this. We all hate it, we know, but we're going to do it. It says solve. Okay, normally when you solve something on the unit circle, you get 2 answers, but I see a 2 theta. So how many answers am I going to have? 4. Okay, so we got to make sure we can find this. All right. Here we go. First, we're going to solve for cosine 2 theta. So we're going to divide each side by root of 2. Cosine 2 theta equals 1 over the root of 2. Okay, we need to rationalize that. What we really have is cosine 2 theta equals root of 2 over 2. I do. Yeah, hold on. You're good. Yeah, you can sit anywhere. Not there. I was wondering if you had changed your mind.
No, I just need to review so I can study it.
Oh, sorry. Yes, back here. Gotcha. All right, so are we good with cosine 2 theta equals root of 2 over 2? We're good there. Okay, good. All right, so what we want to know, all right, is where does cosine, we're going to kind of ignore the 2 for a minute. Where is cosine equal to positive root of 2 over 2? Okay. So here we go. Cosine is the first one. So pi over 4 is going to be an answer. And 7 pi over 4 is an answer. Everybody got those two? Okay, that's where cosine is positive root of 2 over 2. Pi over 4 and 7 pi over 4. Okay, now we're not done because this would be great if we were only between 0 and 2 pi. That would be fantastic, right? If that's all we were between 0 and 2 pi, but we're multiplied by 2. So if I multiply everybody by 2, what I'm really between is 0 and 4 pi. So because of that, that means I have to add 2 pi to both of these to find all 4. That's why. If you don't like this, you don't have to do it. You don't have to even listen to that. You can just know when it's 2 pi, you find your 2 answers and you add 2 pi to both of them. Okay, that's the deal. So I want to add 2 pi to him and I want to add 2 pi to him. That's how you get your 4 answers, because you're not dealing with theta, you're dealing with 2 theta. It's doubling your territory, okay? All right, well, I want to add 2 pi, but my denominator is 4. Well, that means I'm really adding 8 pi over 4. Okay, so if I add 8 pi over 4 to him, I get 9 pi over 4. If I add 8 pi over 4 to him, I get 15 pi over 4. Okay, everybody agree with that? Okay, I really should have put, I'm sorry, 2 theta out there. Okay, so we found it for 2 pi, right? Then we added 2 pi to them to find it for 4 pi. I mean, around. Okay, now what we're going to do is divide everybody by 2. So when you divide by 2, it's the same as multiplying by 1/2. It's the same thing. And you're going to end up with pi over 8, 7 pi over 8, 9 pi over 8, and 15 pi over 8. And there you go. And those are your answers. Okay, so let's talk about it again. Solve for cosine 2 pi, whatever your function is. Find the 2 answers on the unit circle that give you that value. Then add 2 pi to each of them. That's going to give you 4 values. Everybody got that? Once you've done that, multiply them by 1/2. Okay, so you're going to find your 2 angles. You're going to add 2 pi to each. You're going to multiply by 1/2. That's going to give you your 4 that you want. Okay, so if that one bothers you, it bothers a lot of people, put your little steps on your bigger index card. Joseph, remember that big index card you had? That's what you're going to use tomorrow, the bigger one. Okay, all right, got it? Okay. All right, are we okay on that one? I mean, that's the quick and dirty steps, but the reason that it's that way is because we've got 2 rotations in play, and then we solve for the 2 to put it back into 1 rotation. If it's 2 pi, I'm sorry, if it's 2 theta. If it's 2 theta, you do this. And it will be. Yep. Okay, sound good? Huh? What is that? Oh, just leave it there. I'll grab it in a second. Okay, now, so that was your 2 theta. Don't confuse that one with, remember there's a 2 theta. That one said solve, okay? Remember, 106 says solve. Same thing. We did the same thing with sine. So you can practice 106 and you can practice 115. 106 and 115, they're exactly the same. One is sine, one is cosine. Okay, practice both of those. But then remember, 108 gives you tangent in a quadrant and says find sine of 2 theta. If they give you something else, it doesn't say solve, they gave you another function, that's when you're going to use this identity, 2 sine theta equals cosine theta. So that's number 108. It's a little different. Okay. All right. Hopefully that's not horribly confusing. Okay, let's see. 116. Here we go. Okay, so a couple of things you can do here. All right, so let's see. First of all, we're going to do the stuff in parentheses first, kind of like PEMDAS, right? We're going to throw it in here. We're not going to do the couple of things. We're just going to go for that, I think. So, all right, we're going to do this. So what this means is what value or what angle gives you sine, or gives you root of 2 over 2. What angle gives you root of 2 over 2 is what that's asking. Now remember, this is inverse sine. Normally that would be 2 possible angles, but with inverse sine, it's only going to be 1. What are the 2 quadrants you're allowed to look in for inverse sine? Anybody remember? Close, that's cosine, it's the crown. 1 and 4 on the side. Inverse sine is on the side. So these 2 for inverse cosine, these 2 for inverse sine. Remember that? So all that you're allowed to look in is quadrant 1 and quadrant 4. So what angle is going to give you positive root of 2 over 2 for sine? This one, right? Now you don't have to use pi over 4. You can use 45 degrees if you want. It really doesn't specify here. So if you're more comfortable with degrees, you can do that. So this is going to really be 45 degrees, this little dude here, okay? So if this turns into 45 degrees, then what you really have is just tan of 45 degrees. That's what it's asking you to find, okay? So then you'll go back to 45 degrees and find the tangent. Remember, how do you find tangent? Y over x, or sine over cosine. So this guy over this guy, and what's your final answer going to be? 1. Okay, and you're all set. Okay, so do what's in parentheses first. What if this said, for example, inverse sine of root of 3 over 2? Okay, root of 3 over 2 would be here. We're talking about 60 degrees. Then we would have to find the tangent of 60. Okay, so we go back over here to 60. We put y over x, and we're going to get root of 3. Okay. All right. Everybody okay with that? Just do one step at a time. Okay, 117. Find the function value of angle theta. Use a calculator if necessary. Okay, you're not going to need to use a calculator. All right, so we have sine is this, and we're in quadrant 3. Okay, so if this is sine, we want secant. Again, be really careful. One of the choices is going to be negative 11 over 3 because they're checking to see, oh, do you think these are reciprocals? Because they're not, right? That's what they're checking to see. Remember, sine's reciprocal is cosecant, so don't fall for that. All right, so sine is y over r. Y over r. Okay, I'm going to need all 3 of these values. I know my r is positive 11, so my y must have the negative 3. Okay, we're in quadrant 3. So is my x going to be positive or negative when I find it? Negative. Okay. All right. So hopefully you know how to find x. It's just going to be x squared plus negative 3 squared equals 11 squared. Okay, he's going to come out to be horribly ugly. He's going to come out to be x squared equals 112. We take the square root of both sides. Now the square root of 112 is not going to be anything that's pretty, so you're going to have to play with it a little bit. But what you're going to find is that 16 times 7 is 112. So that's going to give you 4 root of 7. Okay, and we know it's negative because we're in quadrant 3. Okay. All right, now all we have to do is put it together. Okay, so you can either remember that secant is going to be r over x, or you can remember secant is just the inverse of cosine. So if you find cosine, you just flip it, right? Okay, so secant is going to be r over x. So it's going to be 11 over negative 4 root of 7. We can't leave it like that. Going to have to rationalize. What am I going to multiply top and bottom by? All you really need to do is multiply it by that root. If you want to multiply it by 4 root of 7, you can, but you're going to have to reduce in the end. Otherwise, this is just going to be 11 root of 7 over 28. It's actually negative, sorry. And there you go. Okay. So you can see x squared plus y squared equals r squared is used in like 80% of this test. Okay, is that all right with everybody? Okay, 2 more and we're done, these last 2. Okay, 118. Both of these are complete the identities. Okay, so I have sine squared theta plus sine squared theta cosine squared theta. Okay, well, anybody have any suggestions? Hopefully you see this and there's one guy that you think ought to be rewritten. Which term do you think ought to be rewritten here? Anybody? The cotangent theta. Because if you notice, well, here's a sine, that's great. Here's a sine, that's great. He's a reciprocal. He's not even one of the big 3. Rewrite him, okay? So cotangent squared theta is cosine squared theta over sine squared theta. I don't, now that I read it down, I don't know if I had that on the list. Okay, I did not put him on your formula list. On the formula list, all I put was cotangent equals cosine over sine. Make sure you know that it's also the squared version like this. Some students have a hard time making this leap. So make sure that you put this on your card. Okay. All right, so let's rewrite cotangent theta. Okay. Yeah, now he looks familiar. Okay. Usually when you rewrite everyone in terms of cosine and sine, something falls out, right? Here we go. Boom. We get sine squared theta plus cosine squared theta. Hopefully you guys all leave this class knowing what that equals. Anybody know what that means? What does that equal? 1. That's 1. And that's one of those that is on your formula list. Okay, good. Okay, let's do this last one, 119. Everyone okay with that one? Okay, let's see what we can do here. I have tan theta, and then I have a little parenthesis package with cotangent theta minus cosine theta. Okay, before I start substituting people, what do you think my first step ought to be? Let's distribute. Let's distribute. Okay, so I'm going to have tan theta times cotangent theta. You don't have to put them in parentheses. You can just sit them right next to each other if you want to. Minus tan theta cosine theta. Okay, good. All right. So some of you may already know what this is going to equal. A function times its reciprocal equals what? 1. All right, if you're not so sure about that and you want to see it, change that cotangent to a tangent. And then you'll see that they cancel and that you're going to get a 1 there. Okay. All right. Now over here, I have tangent times cosine. Who do you think I ought to change here? Okay, so I'm thinking if I change my tangent to sine and cosine, I may be able to do something with this cosine, right? So again, the whole idea for all your identities is take them back to sine and cosine, okay? So I'm gonna do sine theta over cosine theta times cosine theta, okay? So remember, he's a numerator, just in case you guys need to see that. This cancels. What does this whole term become? 1. Good. All right, here, these cancel. What does this whole term become? Sine theta, and you're done. There's nothing else you can do with him because he's not squared, so he's not Pythagorean. That's as good as it's going to get, okay? So in both of these guys, even if on your index card, you need to write identities, change everything to sine and cosine so that you know what kind of cancels out, but that'll get you out of most of your sticky situations anyway. Okay, that's it. Sound okay with everybody? Anybody have any questions? Do you want to see the formula sheet?